All right, welcome in everyone. So today we've got the Altec SolidWorks user group. We've got Brad and Adam here to present, give us some SolidWorks knowledge, some tips and tricks. Daniel's also here, talk about some SolidWorks certificates. And then we've got Michael and Eric with Go Engineer to also give some SolidWorks knowledge. So should be a lot of learning, good time.
You can share your screen on Zoom. We turned you off. Here we go.
Let me know if that's working.
Here we go. You're good. You're live.
All right. All right, guys. Nice to see you. Like you said, we're with Go Engineer. My colleague Chris Helms, you've probably worked with some of you anyway. We are your SolidWorks VAR, your support provider. So just want to take just a few minutes to introduce you to Go Engineer, and just a little bit about our company, footprint, and most importantly, resources and technical expertise. So if we can. Technical difficulties.
I can hit enter.
I might just have you do it, yeah.
Okay.
If that's maybe the next slide, see if that'll. There we go. You can just click through it. Oh, there we go. All right, so Go Engineer, privately owned and operated since '85. Interesting story. We actually started out as an Autodesk reseller. And when SolidWorks came out, our engineer or our owner had the foresight to kind of see that was the future. It was the better technology. You can imagine what a big decision that was, with 10 years of Autodesk customers and working with that tool and then having to basically start over. So it ended up being a great decision. Today we are the #1 SolidWorks VAR worldwide, over 78,000 customers and growing. We have over 300 application engineers that are, there to help you with training, application mentoring sessions, technical questions, really anything that you need to get the most out of your SolidWorks investment. And then we have, training and implementation services to just make sure you're successful with the software. So that's a big focus for us. We do have 50 regional offices throughout the US, so we're pretty much coast to coast. We even cover the state of Alaska. So just to hit on that footprint, we're all over the country. Offices, those training facilities are really there for you, the customer, to be able to come in and get training or meet with us in person. I won't read this to you, but basically just, what SolidWorks does. You guys are pretty familiar, but that's really what Go Engineer is focused on, is just helping customers go live with these technologies and make you successful with the tools. These are, our products, really what we focus on. We come into companies, we hear what your challenges are, and usually these are some of the big ones. How can we shorten product development times, lower costs, reduce product development costs, improve quality, create fewer prototype, reduce scrap. Just a quick, death by logo slide. I only bring this up to show that there's really not a industry that Go Engineer and SolidWorks doesn't touch. Even, from defense to the RV industry here in Indiana to a little organization called NASA, we've worked with these companies, and Altec is one of them that we're proud to support. PDM, data management, we're big believers in that. So just another, a few recent PDM specific customer projects with some well-known customers. I'm sure you're familiar with a lot of these guys. This is just a quote from a really good customer of ours, just talking about that partnership with Go Engineer is what really made their implementation of SolidWorks. They were switching from another CAD tool, and it was that partnership with Go Engineer that really made that a success. Now, the most important part of this presentation is just making sure you guys are aware of the resources available to you here. So tech support is critical, right? We run, because we're coast to coast, our tech support runs 8 to 8 p.m. in the Eastern time zone. Again, we have 3,300 certified application engineers that are there to help you guys do screen shares. Application mentoring sessions is highlighted there. That is not training, but the ability to schedule a one-on-one mentoring session with an application engineer. So something as simple as like, hey, I have this new project. How would you approach modeling this? How would you run this FEA study? Anything of that nature, they're there you can just click a link and schedule some time with them. Again, like I said earlier, training's big. We have 50 training labs across the country. So we do in-person training, but we also have live online training. So same training as if you were to come into one of our offices, same instructors, but you can do it over a web meeting or a Zoom meeting like we're on today. We also have self-paced training. So you can take a class at your own pace, you know, after hours on the weekends, that type of thing. We obviously offer numerous services implementing PDM, helping you automate CAD or other systems, you know, upgrades, customization. We want to go to the latest version. We want to customize something in SolidWorks. Those are all services that we offer. Our Go Engineer customer portal, some of you probably aren't admins, but if you are, this is a great tool. And even if you're not an admin, it's a great centralized place you can go to just kind of manage your SolidWorks licenses, see what you have, who's using what. Admins can assign users based on licenses, so you can see your serial number, what that user's using. If it's a standalone, when the renewals due. Like I said, you can manage users. You can log tech support cases from this portal. And the nice thing for the users is there's a user community. So similar to this user group, but kind of a blog, a web community where you can connect with other SolidWorks users, get insights, knowledge, that type of thing. So it's a great resource. If you haven't signed up, I'd definitely recommend it. That is the Go Engineer customer portal. Chris or I can get you a link to that if you don't have access to that. Lastly, just some additional services we offer. A lot of companies are moving away from on-prem servers and really heavy or expensive IT infrastructure. We see a lot of companies asking about hosting or cloud. They're running other software on Azure or AWS. We do offer hosted PDM. So we take the IT side of it out of it. We'll actually acquire we'll maintain the server for you. So I think we use Azure, but whether it's Azure, AWS, we are the IT providers of your PDM environment. So if you guys have PDM or want to look at, you know, having us host it for you, we can do that. It's a service we offer, and it's really been growing the last few years with a lot of companies. Again, PDM implementations, something we do all the time, help you get it set up, make sure, you know, work with you on how you want the workflow to look, and just make sure that there's successful adoption of that tool. API, CAD API automation, we do a lot with, you know, helping companies automate redundant tasks, duplicate data entry. There's all, you know, the sky's the limit when it comes to automation, a lot of services that are available there. So that's it, guys. I appreciate you letting us take a few minutes just to introduce some, you know, Go Engineer and some of the services we offer. If anybody has questions, feel free to connect with Chris or I. Check out goengineer.com, and we're happy to help however we can.
Mike, we got a +1 in the chat from Zoom from Depop saying you guys are the greatest already done.
Awesome. Well, thank you. We appreciate that. Good job. Thank you.
Make Daniel the host, and then you're good to go. Thank you. Share the screen.
I'm not sure.
Click on Daniel and the little buttons beside his head. You have to stop your share.
Oh,
I'm
No, I'm good. We're switching computers now, everybody. We'll be back in a couple minutes.
I'm just gonna leave it.
sign Daniel right there. There you go. Mm-hmm. Yeah.
Awesome. Thank you. Let him do camera. Let him do the camera. He's gonna stand up. Gail.
Can everybody hear me on Zoom?
Yes, you can meet your machine.
It's not my machine.
I think you're right.
It's on the TV.
Oh,
Hold on.
it is. It's
Now, there we go. Shut the
Alright.
TV up.
Okay. Thank you. And let's give Michael a round of applause from going here. So I want to kickstands up for SOLIDWORKS certification. By show of hands, who here has a certification in SOLIDWORKS? 1, 2. What do you have? Professional. Professional. Excellent.
I've got 2 of the
advanced.
Yeah. Does everyone else in here use SOLIDWORKS? Well, this would be a really great meeting for y'all. My name is Daniel Granillo, and I joined SOLIDWORKS 8 years ago. Became a CSWE expert, something that everyone kind of strives to achieve in their SOLIDWORKS career. And got a bachelor's in manufacturing engineering from Cal Poly Pomona. Motorcycle riding 10 years, SOLIDWORKS 20 years. And I reside in Knoxville, Tennessee, and Sturgis, South Dakota, going back and forth right now. But I remember when I was in college coming to a meeting just like this one, and I was not certified. I was just starting to learn SOLIDWORKS, and they gave out some free vouchers to take a certification exam. That was a CSWP. And I was like, all right, that's something I can add to my resume. And I took that and failed. But that did not deter me. I mean, so I took it again and passed. And when I got my first job after college, everyone kind of looked to me because I was the only one certified in the company with the certification. Hey, Daniel, how do you do this in SOLIDWORKS? How do you do that? And by sharing, by not holding within, by sharing the knowledge, it kind of helped me advance in that role there. I then, in that company for 10 years, kind of grew to become like the CAD manager of the company worldwide, and then managing PDM. SOLIDWORKS kind of picked me up after that, and joined the certification team. And I'll talk to you a little bit about some of our certifications, a little insight, and how to get the best out of SOLIDWORKS that you can with our certifications. In all these industries, automotive, here at Altec, I mean, that's kind of like almost your industry, as well as manufacturing and processes, and with those cranes that you have on those trucks as well. But in all of these industries, what do you think they have in common? Yeah, CAD. Yeah, SOLIDWORKS. Yeah. So why not, master? I'm not really going to try and sell you, but master your skills, with the SOLIDWORKS certification. You may see, I don't know if you can tell, but there's some rain clouds up ahead. You may not know exactly where to start your certification journey. Sometimes it may feel like, driving through a small town. And it's like, you'll get going and you'll gotta slow down, and then try and pick it up again. But where do you start? We have different levels of certification that you can accomplish on your journey. Does anyone know the first level of certification? The associate, yes. And what about the second level? Professional, yes. And the third level? Expert, good job. So yes, we have 3 levels of certification. And
within our SOLIDWORKS certification program. The first being the associate, that's designed for anyone who has taken a training course or essentials. We highly recommend going to your reseller. They're the best at what they do and sharing their insights and knowledge for these trainings. But any real training within SOLIDWORKS, you can take the associate to just prove the mastery of your skill level as a benchmark. And then when you get at least like 6 months experience and you're a little more proficient at that tool, you can then take the CSWP, the Certified Professional Exam, which is geared to time efficiency, how well you can design for change, configurations. Brad did a really good presentation yesterday on configurations, I believe, and how to best use them. And so all those essential tools will help you. And then the third level is the expert, which for we have a couple of experts here in the room, the presenters, there's a roadmap to getting to that level for the expert. And what that pretty much entails is the CSWP, which I believe you have a leg up on that. And then do you have any of the 4 of the 5 other professional exams that qualify? What do you have? Sheet metal and drawing tools. So you also have weldment, surfacing, and mold making. And I can tell you, if you don't have any experience in mold making, that's one exam that I help to update, where you actually need to know, industry knowledge of mold making to really pass that exam. So I would recommend the other 2, like weldments and surfacing, to qualify you for that because that's there's a complete exam dedicated to the expert and level exam for CAD design. And then does anyone know we have another expert exam available as well? Does anyone know what that is? Simulation. Yeah, we have an expert simulation track that you can obtain. Fewer certifications to qualify, but just another track that you can achieve to become an expert. And if you have an opportunity to visit 3D Experience World, Brad, he did a presentation in Nashville on, some of the benefits of going to 3D Experience World and how to justify that trip. Well, becoming an expert, there's some incentives there that we give to just celebrate all the experts around the world. And so that's for the simulation track. Now a little bit, some updates that we've done just to educate you on what we've been doing this past year. We've actually consolidated some of our exams, as well as we did some name changes just to bring to your attention. And one of those is with our SOLIDWORKS desktop, the CSWA, and we also have a CSWA on the platform for SOLIDWORKS. Well, now, with the SOLIDWORKS connected app on the platform, it's become, almost in line with the SOLIDWORKS desktop, where you can take the CSWA with any flavor. So we really, just consolidated those 2 certifications. And now we have CAD design. This is our CSWA, the associate level. There's just 1 exam, 1 certification you can take, with the platform or on the platform. I know Brad and Adam, they're using the SOLIDWORKS connected app for their, presentations. And it's, with the exception of the reload, it's very, very similar with all the functionality and tools. So it's getting there. So we hope by the end of the year, the SOLIDWORKS connected app will be in line with the desktop version. And then for the CSWP, we also consolidated those 2 as well, the 3D Experience SOLIDWORKS Professional Certification, and then also the desktop. And we combined that into 1 exam, 1 certification. There are more hands-on challenges and data sets, now in that 1 exam, but essentially the same difficulty level. Some name changes as of June 2024. For our platform certifications, they used to be called 3D Experience. A lot of them had 3D Experience in their names, 3D Creator, 3D Sculptor. Now it's we changed all the names to the brand. So now it's SolidWorks 3D Creator, SolidWorks 3D Sculptor. Has anyone used the 3D Sculptor, the X shape on the platform? Yep. Yeah. It's if you do any kind of surfacing, that's the app for sub-D modeling. You can create some really great geometry surfacing wise. And these two actually did a presentation at World where they designed a whole fairing on a motorcycle and showed how you can bring that into SolidWorks and how the two went back and forth with one another. So for most of our platform certifications, we just rebranded them or changed the name to the brand. And for all of our desktop SolidWorks certifications, the only change that we made was the mechanical design for the associate, professional, and expert. It's now called SolidWorks CAD Design, associate, SolidWorks CAD Design Professional, and expert. So we have just over, I believe, 17 or 18 certifications for our desktop or for SolidWorks. And does anyone want to take a guess at, for the top 5 most, certified users around the world, which certification that would be number 1 around the world? The associate? Yeah, we have 500,000 certified users around the world at that associate level. How about number 2? The second most certified around the world. Professional, yeah, that's it. 120,000 certified users. Number 3. Expert. What about online? Any guesses online?
We've got sheet metal. Yep, we got a sheet metal and somebody's been drawing lines on the screen.
Okay, yes, number 3 is sheet metal, followed by number 4, drawing tools, and number 5 is the CSWA additive manufacturing as far as certified users around the world. No. Yes. And be sure to stick around to the end of the presentation if you're online. There'll be a QR code, a short little survey that you can fill out where we're actually going to be giving everybody here today and online a free voucher to take a certification exam. Anyone, actually, you get the CSWA, the CSWP, and any one of our other certifications except the expert. The expert is the only certification we don't give away for free or discount. But I will say, when you're ready for that, and if you fail, you can contact us and we'll be happy to give you a free retake.
David Mendel from Smart up in Milwaukee, where we'll be tomorrow, says, wait, so the PDM admin one is called CPAD?
Yes. So my contact email, you can contact me direct. We also have an inbox that we respond, to customers that you can contact us at, as well as, the 3D Experience Certification Center, where you can actually see, everyone that is a certified user. Here on the left, you can look up certified users, and for our experts around the world, we have just over 7,000 certified experts around the world. For CSWP, the professional level, we have 23,000.
235,000.
235,000, yeah. We can narrow it down by state. So we look at, what state are we in?
Indiana.
Indiana.
Well, like,
So in Indiana, we have 427 CSWPs here in the state of Indiana. And you can actually, browse through here. Let's say I was looking for someone from Altec down in here. But you can also list your LinkedIn profile and see what other certificates that you have. So really great way to showcase your certifications. So with that, my presentation is over.
You mentioned the survey.
Oh.
For the survey.
Yes, we also have a gift card. With the survey, we just want to send a special thanks to HP for donating the gift card. So when you fill out that QR code, that little survey, there's a free gift card that will be given away as at random. So not everyone's getting the gift card, but someone will. Yeah. So thank you. And Brad is going to come up next and talk to you about some great ways on how you can leverage large assemblies and be able to work with them.
Yaya asked if we should do the survey every day, and yes, you can fill it out every day.
Yes, you can fill a survey out every day. It'll just put you at a better odds, maybe getting one.
Yeah, you
throughout
might,
the week.
it might increase your odds.
May the odds be forever in your favor. Sorry.
You just went super nerd there, but let's, there you go. I am the host.
There's not too many people online, is it?
Not too many at all, huh? All right. Put this down here. All right. Now that we got everybody going here, got myself all set up. Everybody can see everything okay. Daniel, if you want to hand me the HDMI, that way we don't have to worry about your computer being connected anymore. We'll go direct here. Keep everything easy for you. That way you can, pack whatever you want, that kind of thing. Okay. There we go. Okay. All right. So today I'm going to go over easing the pain of large assemblies. I know we here at Altec build full trucks inside of 3D SolidWorks. And if you're like me, you hit open, you can go grab yourself a cup of coffee and wait, or hit swim save and grab yourself a cup of coffee, go get lunch and come back sometimes, depending on what models you get and how complicated they are. We can blame the body, guys. I'm sorry. All right.
Guys are perfect.
All right. So, how do I get this to go away? Let's move this up here all the way. All right. So first things first, my name is Brad Meador. That's my government name. I typically go by Tank. Let's see if I can get this thing to stop showing up. Here, let's hide this out of the way. I go by Tank. I'm a husband to dad, a project designer at Altec in Roanoke, Virginia. I work in the new product development side, so I do cranes, the large digger derricks, and the DT line, so DT65, DT85, and the big cranes. I'm also a user group leader for Roanoke, Virginia. We're called the Star City SWUG. In fact, the city actually has the star. I have it tattooed on me. We have a 80-foot illuminated star on one of our mountains. That's why we're called the Star City. I'm also the Mid-Atlantic state rep for the SWUG committee and a SolidWorks champion, as well as a certified SolidWorks expert. I actually went through the whole process in 2017, 2018, and took everything I could when I had the chance to do it. And I had some time to do it. So really rewarding to get it done. And with that, he was talking about some benefits of being a CSWE. When you go to World, they actually have a private party they invite just the SolidWorks experts for, and there's 7,500 worldwide, and there's only maybe 1,000 that show up to, even if that, maybe a couple hundred that show up to these big events worldwide. So you get to kind of hang out, network with other people, and kind of nerd out over their favorite things. And obviously we all love the events that they throw. So some key takeaways for today. What is a large assembly in SolidWorks? We're going to go over some tips and tricks on how to deal with large assemblies. We're going to go over some drawing tips and tricks. And then we're going to go over PC tips and tricks. Now, depending on your IT department and how they do things, some of this might be blocked, but most everything I believe I covered in this can be done by everybody, even in person here at Altec. So now it's your turn to answer some questions. What is a large assembly in SolidWorks? Chat, feel free to answer as well. Let me get my cricket sound effect out for more than 20 components. Okay. Huh?
I'm gonna go 10,000.
10,000. Okay. 20 megabytes. Okay.
Crashes my SolidWorks.
Crashes your SolidWorks. Okay. That's a great one here. Let's hide floating panel controls. There we go.
Deepak says an assembly has a very high number of components, probably over 500.
Okay.
One that is annoying to open from David.
Annoying. Annoying to open.
Bill Rogers says 500.
All right. So, physical size. I talked to somebody at World that builds concrete plants in SolidWorks. I'm like, that's a large assembly. They're like, no, not really. It's actually fairly simple. It's I-beams. It can't be that complicated, right? I'm thinking physical size when I think of large assemblies sometimes. Is it complex parts, 500 parts, 1,000 parts, megabytes? You got 20, you got 500, whatever you think. Well, the definition really is it just whatever file uses the most of your resources or significantly slows you down. It could be a part that is just a single part. It's got all these crazy shapes, cuts in it that has thousands of graphics triangles in there, tens of thousands. It could be something like a valve with all the parts inside. We're talking hundreds of parts that slows you down. It could be a full plant layout or a full truck layout. It could be any of those things. It's just whatever uses your resources and slows your workflow down. So just keep that in mind. So if you have something that's really slowing you down, that's considered large assembly to me. So we're going to start with large assemblies, and we're going to show how SolidWorks actually thinks. Hopefully. That's AI hasn't got me yet. Okay. All right. So how does SolidWorks function when updating or opening an assembly or drawing? Okay. You think you just hit open, right? And it opens the file. No, it actually does a lot of things in the background before you even see a thing. Most of the time, it's pretty quick. But we're going to step through the process here and then how to kind of make your job a little easier for it. So I'm Joe Designer, and I'm going to open my assembly or assembly drawing. I click the open button. In the background, it starts loading all the reference parts and subassemblies. It does that by going down the feature tree and finding everything that needs to load down the feature tree. After it finds all the subassemblies and files, once it finds them, it says, did anything actually change in those? So it's querying those files. And if it has, you have to update all the visual and calculation aspects of those files ahead of time before displaying them. So then it's going to go through and find all those parts and subassemblies with parts in them. And if those parts have been updated, it has to update those subassemblies and the parts that are included. That's the SolidWorks AI over there coming after me. So keep it, we have got double track here. All right. The bottom one is no changes since last save. The update parts is up at the top. So now that it's loaded all the parts, it's updated all the parts. Now it's got to solve all the mates before it does anything else. So it goes in and actually goes one by one through your mate folder and solves them in place, which is physically putting all the parts where they need to go. After it gets all that solved, it does in context features. So things like if you're doing an assembly cut or you're doing an assembly pattern or anything like that, then it does the patterning and things in context. Now, if you happen to mate things to those patterns, it's got to go back through, sort the mates again, and reload, causing a circular loop. So that's a little preview of what is to come. So go to the next slide here. And then it displays the results on the screen. Kind of complicated, right? Just to open a file. Okay, so here's the whole process for creating a, or for just opening a file inside SolidWorks. Oh, yeah, big deal. How does it apply? Well, think about an assembly that you've opened and it's taking a lot of time. Which part of the process is it slowing down on? So we're going to go into some large assembly tips and tricks now and kind of go from there. So first things first, SolidWorks settings. Now I know here at Altec, we deploy a standard out of the box set of settings. Okay. Yeah, set of settings. But we do, the admin image has room for you all to make your customizations. In the chat, you guys, depending on what company you're at, you will, depends on what they allow. Sometimes you're not allowed to change anything. Sometimes you're allowed to change everything. That's kind of scary. So, both. It is kind of scary. All right. So, we're going to dive into our large assembly settings here. And so it's going to be on the system options side. Under assemblies, we have some options here that I like to keep selected. I typically don't do autosaves on large assemblies when it's in large assembly mode, so I turn that off. Do not rebuild when switching between screens. I hide all the planes, sketches, and annotations inside of assemblies. No edges. Amazingly, the edges in your display mode, while it looks nice, you can see the crisp edges and things. That actually slows the calculation down because it's having to draw that line in there to showcase it rather than just having smooth edges. Do not preview any hidden stuff, so it's not going to load it and load it in cache. And then optimize the image quality for better performance. Now, I know at Altec we have our model health checker that allows us to do that, but inside of SolidWorks, it gives us an option to, I guess, up or down convert from high quality down to a lower quality image. And then suspend automatic rebuild. And so large assemblies, all the settings we can change in here. And then down at the bottom, if you have envelopes, if you do envelopes here, I know the body plants are starting to use those. I know we're starting to kind of incorporate them a little bit more for building, sub-assemblies and whatnot. Have them as automatically loaded as lightweight, and then have them loaded as read-only. That, I believe, will do anyway with SWIM, so I wouldn't worry about that.
Well, I think actually, we changed the setting this year when we went to 22, where it's auto.
Yes.
Lightweighted auto does its own thing.
Yep. 23.
Sorry, 23. Yeah.
Yep.
It's updated 23.
So I'm going to jump over into our favorite software, or not favorite, depending on how bad your models are. And we're going to open up our system options. Now, I'm on 2024 connected, so the system options and stuff may be a little bit different than what we have at Altec, but we have the large assembly settings here, and I can pull up I can set all these things the way I want. And then envelope components, looks like they've updated it to say automatically load lightweight, but not the read-only option. So that's going to be a little bit of a different setting. You're allowed in here to set file sizes for large assembly mode or, part sizes. So always have these selected. If you have more than 500 parts, it'll automatically load as large assembly, and it will start doing these settings the way you want. 5,000 typically is the default for large design review. So I believe our trucks get that high. A full sales drawing will get close to that. But you can always change that a little bit and update it so that every time you open up that sales model, it'll automatically be in large design review, which will speed up your stuff, which we'll show in a little bit. So here's your default numbers. That's just how it's set from SolidWorks. If you want to try to set your own, go for it. If you know that your assemblies are going to be less than 100 parts most of the time, you're fine. You can bring that number down, and anytime you just have a free range to do it. Image quality. I know, again, with our model health checker, we set our image quality down, but let's see. Hold up. Pull up my pen here. All right. We're going to draw a line straight down, as straight as I can get it with a mouse without an actual line command, down these bars. Try not to get your image quality over that middle point. The farther left you get, the choppier the image is going to look, but the faster your computer is going to render that image, because it's having to take each face. So like this as a cylinder, you think it's one surface. It's breaking that one surface into individual triangles to layer over top to create the image. So when you have bigger triangles, easier to calculate. When you have finer triangles, more calculation time. It's kind of like doing mesh and FEA. If y'all are familiar with that, the finer the mesh, the more accurate your FEA is going to be, but the harder it will take, or the longer it will take to calculate. So that's kind of along the same frame if you're used to that. Sometimes I get in the habit of, if I'm doing some, prototyping, I get tired of seeing the choppy lines. I'll bring it up a little, I'll scoot it up a little bit on my document properties to see some better smooth images. But I'll always run model health checker that we have, add in and bring it back down to the 10% setup that we have. But this is natively set up in our start part to be low, far to the left as we can get it without it looking too bad. So when you're opening big assemblies, start looking at these settings when you are having issues. So this setting was turned on in 2023, or given to us in 2023. Under the performance tab, in system options under the performance tab, it's automatically optimized resolve mode. Hide lightweight mode. So in previous years, you can load it as fully resolved, lightweight, or large design review. Now you are given resolved or large design review. You turn this setting on, it'll find all the subcomponents of an assembly or of a large assembly, and it'll just load them all lightweight, and then the assembly will be the only one fully resolved in this mode. At Altec, we have this set out of the box, especially with large bodies, large assemblies, or large full truck frames and stuff.
The only bug that I'd say I've seen with this, and I don't know it's a bug, I think it's its intent, but I'm not a super big fan of it. When you do lightweight on its own, you get a little feather next to your parts, right? And it lets you know it's lightweight. When you use this, and it's something we've got on it, it definitely helps you on EFA a lot more probably than it does as a body plank. You have so much more, so many more parts, right? But it no longer puts that feather in your feature group.
You can see it in the swim pane.
You have to look in the swim pane to see it over there. Another thing too as well is If you're trying to take measurements or trying to pick midpoints for measurements, because they're not fully resolved, because they are lightweight, you can't pick a midpoint when it's lightweight.
Yep.
Before you could expand it in your feature tree and it would resolve it. Now you have to physically go and open the part to get it to resolve and then come back.
Or tell it to set to resolve in the feature
Or-
tree.
Actually, I don't even think it's there now. For
Yep.
that.
So this was brought in 2023. This is a setup on all of our stuff, at least our company deployed laptops.
Yeah, resolve not the feature tree. So I'll make that.
Well, now that you got your settings, let's get to work. But wait, there's more. Slow down before you do anything. Think before you open, and then ask yourself before you do anything, what kind of work are you going to be doing? So we got two camps, right? If you're opening a file, you're either going to be modifying that file or referencing or viewing it or showing it off to a customer or a supervisor or a colleague. So we'll start with modifying your large assembly. Well, we're going to start opening this part here. And it's 42 megabytes. Pretty complicated. This is part of a sales model for a crane. So I'm sitting there thinking, this is going to suck. And for people who are older than the age of 30, you might recognize this movie instead. The sweating happens. Of am I going to crash it? Do I have everything ready to go? Do I need to go get a coffee break? I don't know. We're going to do an investigative open first on anything that I've never opened before. We're going to jump back into SolidWorks. I had it all set up as a shortcut, and then I got a new PC and put it all together here. So I'm going to do an investigative open. I see we have a PT number here, and it's really, really large. 129 megs for that PT number. Pretty big file. I don't know if I necessarily want to just hit go and see what happens. Be kind of scary, I think. But we'll just start with the sales model here. And before you click open anything, go to your configuration tab on your open, drop down to advanced, and then click open. It's going to prompt you with the screen. Don't make me a liar. Come on now. There we go. And it says, okay, do you want to open the configuration you have that's saved in there? A new one showing reference models only, or one that's structure only? This is what I want. This is what you're going to want if you're opening a sales model or opening something from a supplier or something. And you're going to create a new configuration when opening that we can put in. And it's just going to be the structure only. So what's it going to do? It's going to open that file. Nothing's going to be in it resolved. But now I can see all the parts that are listed. Come on now. I can see all the parts that I'm listed, what files are going to be where, and start rolling them back, unsuppressing them or activating them, and seeing where our issues are going to be. Why is this file really large? Is it the shape of the part? Is it the number of parts that are in there? What's going to be causing my problem? Now, because I just picked the chassis, it might take a minute. But it's going to look for that file and it's going to pull it and resolve it, fully resolved, while the rest of the stuff stays suppressed. And it's going to make a liar out of me. It's going to crash, I bet. We'll see. Well, while that's waiting, going over, we'll jump back into the PowerPoint. So we'll do that. I'm going to show it to you again just in photo forms for the people that are on the Zoom, so they can kind of get screenshots and stuff. But find your model you want to open. Click the configuration drop down, go to advanced, pick the configuration you want to, or create a new configuration of structure only. and then it'll open with everything in there suppressed. So you can just kind of work your way through. So with that, since we have a little bit of a time crunch, I simplified some stuff in here. For big assemblies, what you're going to want to do, start working on configurations of parts that are simplified. If you got placards, make sure that none of that text is extruded. Suppress those out as a simplified configuration. Anything that's not needed in the top level assembly, get rid of. If you're working on a sales drawing, you don't need to see every piece of hardware in there. Suppress all the hardware. It doesn't have to load them, and then it's not sitting there calculating all the space. In part files, step down, find all the fillets and things that are not needed that make it look pretty, and suppress those. Yeah, because this looks good. It's got fillets on the edges and fillets on the edges and lots of fillets and chamfers here. But if it's this 3 or 4 sub-assemblies deep, I don't need to see all that. Basically, all I need to see is just a cylinder to hold space. You can create a sub configuration of just a cylinder and defeature it down. Use sub-assemblies. Step away from that mindset of throwing everything into a big model. Start building on sub-assemblies. The less mates, the faster the solve time, because it's having to go through the tree, load the mates, and then if you're doing patterns, we can do that as well. No circular references. Don't make to pattern or mirrored parts. Anything that's mirrored or patterned, then you need to mate all the stuff that holds it in place. So if you have a L bracket mirrored over from one side to another, that hardware should be mirrored as well. It shouldn't have more hardware mated to it. Otherwise, you're creating that circular loop opening and correcting. And then fully define all the time. Don't make me play Toby Snar's video, because then you'll be sitting here singing it tomorrow all day. Okay? When you have fully defined sketches and fully defined parts, it actually helps the software solve faster, because the software knows this part is in this location, this mouse is here, it will not move. I can display the rendering and lock it here. But if it's movable, it's having to anticipate where it's going to go. So if you have hardware, lock rotation, hold it in place.
Yeah, I gotta say, please play it.
Oh, no, I'm not going to do that. I don't want to be singing it in my helmet for 4 hours while we drive today. So, big stuff, limit your complex features, helical sweeps, threads, get rid of them. If you download parts from McMaster-Carr, double check that stuff. They have the image quality cranked all the way up. They have all the threads shown in, all the fillets there, everything's in there. Defeature your parts down with simplified configurations. Patterns and mirrors are your friends. Use them. They are a faster calculation, because instead of having to find and recalculate where this new screw is going to be, it's just moving the body.
Well, Roger's had a question. He says, I understand fully defined, but if clocking the part doesn't matter, bolt, does it need to be locked down?
Yes, it does. It does need to be locked down, because SolidWorks is not having to think, where is this going to move to? It might be just locked in place, but spinning but the software is having to anticipate the change. AI. You can just use that as a term. All right. Local files. With us, Altec, we're good. We pull everything from a PLM to a local drive on our machines, except the one I'm working on, because I'm working off my Google Drive for this presentation. But what it's doing is it's eliminating the network problem out. You're not having to transfer data across fiber or across CAT lines. You don't want that. You want to be able to just use your machine as a resource. So if you are working like on the Zoom calls, if you're using a network drive, try to have it so you can open it direct from your machine. Also, save to the current version of SolidWorks that you're using. When SolidWorks opens, if it's I believe it's more than 3 years old now, they will have to convert all the background calculations and things to showcase that part and to get it up to date. So if you have everything up to your latest version, it eliminates that step from the calculation. I know at Altec, we run those automatically when we do an upgrade. We actually run a script in the background to update all the stuff to the newest versions on parts. Assemblies you can't do, but parts. So now we've gone through, I've made this really sweet model to use. I'm going to show it to my boss, but I'm going to do that tomorrow. So let's jump back to our machine here. Oh yeah, there it goes. See what happens when you pull it off the network drive. It's got to download through the Wi-Fi. But let's close that back out. So now that we've created the model, we want to show it off to our customer via like a PAM kit, or do we want to show it off at a trade show, or we want to show it off to some of our buddies? Like, look what I designed this week. So don't fully resolve the model. If you're not planning on doing any work whatsoever in there and you're just showing it off, don't resolve the model. Use large design review. It is the shortcut. So we'll do the same thing here. We'll open this assembly, right? This is a full cells model. It's 100, we'll open that there, 169 megabytes. We can go into our open tab, click large design review, and it'll open there. That's under your recents. But if you're going to pull it from open, you can do the same thing by clicking the part, selecting the slider to large design review, and hitting open. Another way, which I learned from Alin, we'll pull it here. If you're going to grab and drag, this one's one I learned here recently. Click the part, hold the Alt key, drag it down. I believe, let's see if it does it on the connected version. It should pull the open screen. If not, I just wasted everybody's time. Yeah, I didn't. So it looks like it's going to resolve it. But I believe when you click and drag it in, or click and hold Alt and click open, it should allow you to do that. Let's just stop that real quick and close it. We'll crash it. Oh, taskbar settings. End task. There we go. All right, we'll just do that. We'll pull that up again. Now I've got myself curious and I want to make sure I get this right. What you got? Oh, my mouse is still. All right, there we go. We'll open that back up again.
You talking, yeah, you're saying hold off.
I did hold Alt and drag it in. So I'm wondering if it's the connected version.
I think it's a solid connected thing.
Okay. We'll try it with Alt and then click the button.
It's first crash of IronSWUG 24.
Nope, if you hit Alt and click it, it won't do it. Okay, so on regular SolidWorks, you hold Alt and drag it in and it'll open your auto. It'll open the, dang it, I don't want that. What'd you say? What?
Epoch says drag in and then before leaving, hold off. So maybe it's the timing of when you hold off. I don't know.
I don't know. We won't worry about it right now. There we go. Interesting. Well, I somehow broke SolidWorks and Zoom and the TV. Does everybody on Zoom still see me? Okay, good. Just want to make sure. I don't want to break
I
everything.
can't get rid of that.
I know. Okay, now, Jesus.
Actually,
There we go. First crash of IronSWUG 24. We go to our recents tab. We're gonna go resolved. We're gonna click large design review. How long do you think this will take to open with a full sales model? Crane. This is a crane being pulled off of Google Drive currently.
Anybody in here use LDR? 45 seconds.
45 seconds?
Anybody in here use LDR?
A little bit.
Yeah, it's amazing. If you don't, try it.
All right.
It'll take a model from 10, 20 minutes and open it up within a minute.
Let's see. I've got a stopwatch going. We'll see what happens. All right. This is telling you what you can and can't do in large design review and giving you the warning that you're opening it as a view only part.
Still have some things they can do. They actually released or told us that world for next year's rollout. You'll even be able to make cut extrusions and
Yep.
stuff on LVR.
Yep, we'll be able to do that. All right, so, okay, stop. 38 seconds for a full sales drawing. All the parts are there. You might be able to see the icons have a little eyeball on them. You're just viewing them. You open inside the parts all the way down to just the parts. There's nothing underneath the feature tree. It is just a graphical image. So if you're doing a PAM kit or you're showing off something to your coworker, this thing, I mean, it works really well, fast. You can do what you need to do to display. Then come back in later and say, I want to do a selective open and pick the things you want to update. So if I know this section of the boom here we want to do, we'll go to our selection tools. I'll select what I want to select to open. I know I'm just going to work on this section here. Do my selective open, just those components. It's going to open it and show only those parts that I'm trying to work on rather than trying to reload and resolve everything that I want. So using this tool will help greatly expedite your process when you're trying to do drawing creation or part creation. So now all the parts that I'm looking at working on are fully resolved. The rest of them are hidden. And I can go back through and find the things I want and unhide them as I go. So we'll kind of pause on this screen here. The pop-up that comes up says these are the things you can and can't do inside large design review. Allow you to create section views, hide show components, and walkthroughs, but it will not allow you to insert, delete, move, or edit mates unless you tell it to edit the part, which is a newer feature where it'll give you some more data you can compile. So it's a limited amount of functionality. You cannot add things. And if you have an assembly feature like an extrude cut that goes through something, if you've got a piece that's welded together with a bunch of parts and then extrude cut for final machining, you will not be able to edit it. And if you have any flexible assemblies, it won't allow you to go in edit mode. So you'll see we got your own tab up there for large design review only. This gives you everything you can and can't do hidden as needed. And as you can see, you got the little eyeball there showing beside the Lego brick to let you know that you are just viewing those parts only. So now that we've got our assemblies done, we're working on them. Now we got a drawing, right? You got to always have a print currently. So keep in mind, you open a drawing, it's got to go through all this process up on the screen with the part first before it attempts to open the drawing. It's got to open, you got to tell it to open, and it's got to load all the reference parts, and it's got to update any changed subassemblies, solve the mates, solve in context features, and then display the, it doesn't display the results, but afterwards, it finds any configurations that are referenced in the drawing. It updates those. And if it has parts that weren't loaded in that configuration, it's got to go back through, find all the parts, upload them, and resolve them inside the drawing. Then it shows all the updated assembly views as draft quality, and then the high quality views are getting solved as you're looking at the screen. It's displaying them as draft quality while it's resolving all the images. And once it goes through draft quality views, it starts solving the dependent views. So if you've got detail views, section views, that kind of thing, it locks those down afterwards and then converts them to high quality, which is a better view. It's not as pixelated. And then afterwards, it displays all of that on the screen as a specific line font or whatever layer. So with that, we'll do some drawing tips and tricks. How much time we got? Okay. So think before you slow down, or slow down, think before you open, and what kind of work are you doing? Are you modifying or are you viewing? Same thing as before. If you're modifying a drawing, you can go into detailing mode or resolve mode. And look, that drawing, sales drawings, 169 megs. Pretty sweat inducing. I'm guessing people older than the age of 30 know that one or that one. Load only the sheets you need. So if you're only modifying, you have a 10-page sales drawing, you're only going to modify just the 2 pages you want. Go into your open tab, find the drawing you want to open, select the sheets you want to pick. That's it. All the rest of them will be view only. It'll only resolve the parts that are in that page. So if you've got different zoomed in features on different pages and you only want to work on one page to update, load the sheets you need only. So if you're reviewing it, use detailing mode instead. Detailing mode loads the print in view only mode. The whole thing would be essentially lightweight. The whole drawing is. So you got your detailing only selection. And to fully use detailing mode, you have to tell it to, in your document property, to save your model data inside the drawing and the view palette, with the caveat that it's orders of magnitude in size, file size. We're talking 2 to 3 times file size. So just be very careful if you're doing something with a sales drawing or you're doing something with a large assembly. It'll actually make your drawing very large. So inside detailing mode, you'll get a warning at the top. It says, hey, these are the options you're allowed. The rest of them are not allowed. So if you want to resolve the drawing and do more stuff, you can do that, or you can actually just use the options that are available on the screen, creating notes, dimensions, things like that. So, but if you don't want to take the size hit, you can view the limitations. These are the things that are what you won't be able to do. These are not available in just view only mode if you're not doing any editing. So some tips that kind of go between drawings and assemblies: limit your configurations. They add 20 to 30% file size, usually per configuration. The more configurations you have, the bigger the file, obviously, but the longer it takes for it to load in the print. Use display states instead. So we'll just I dug through this yesterday. We have a drawing, lots of configurations showing very different things on each page to convey the information. Using configurations, hiding and showing parts. I'm not mad, but I want to know who did it. Instead, we converted it to use display states instead. And you have a 10-minute time savings in swim save dialog. Opening time is roughly the same, or 61% savings, and the file size, the drawing size went down 30%, and the assembly size went down 42% by limiting the configurations you use. So think before you start doing big prints. Machine tips: set yourself up for success. If you have if you have access to it, get 64 gigs of RAM installed in whatever machine you're using. 32 gigs is I consider the bare minimum. 64 is better. Faster CPUs get you up. We're talking 5 gigahertz single core speed. You want to be able to get it working. Solid state hard drives, most everybody uses that now. Faster open and saves than disk drives. And then use do not use gaming GPUs, use actual enterprise GPUs. I know some people will try to cheap out and use gaming ones because they are cheaper, but the calculation engine inside of them are different for gaming versus enterprise work. So this one in this machine's an A5000, fantastic machine. So kudos to HP for giving these to us for the week. Inside your Windows, you can go into hardware accelerated GPU scheduling, and you can tell it that in SolidWorks, I want to only use the NVIDIA graphics card. If you say let Windows decide, it'll attempt to use the one that built into the motherboard. You want it to use the one that you put in the machine that you specifically built into it. Now this image was taken from my work laptop, so it's got the A3000 in there. But you can tell it, I want this to only use this graphics card. So if you know that's what you're going to do for renderings, you can do it with rendering software as well. And then monitor your resources. Open up your resource monitor and find the problems. Close unneeded programs. Amazingly, Chrome and Edge are massive resource hogs because they're just a window to whatever code that they want to run. So I got a photo here. Yeah. So I have 2 tabs in Microsoft Edge open and SolidWorks open at the same time. Microsoft Edge is almost using a quarter. It's like a quarter of the same or of the bandwidth that SolidWorks is using. And you would think just having like my page open for my Team Center page open on Edge would not take much resource, but it really does. It'll build. And obviously the more tabs you have, the more resources it will take. So if you're having problems opening large models, close all the unnecessary programs. Let SolidWorks take the resources that it needs. So take your time with large assemblies. I know it's kind of arduous. Make sure that, you know, if you're going to do work on it, open it the right way. Share this with your team, you know, reach out to all the people and then reach out to the VARs. You know, we got Go Engineer here today. If you're having problems with them, they have signed all the proper documentation where we can send them crashed files and do your screen recordings and stuff. They can actually, in their support network, try to recreate the problem using our files and give you an idea of what's going on. So use them. Any questions so far?
All right, so yeah, none of it would be possible without our sponsors. Of course, you guys know we work for Altec. If Altec didn't allow us to get out on the road and go to different Altec facilities as well as facilities outside of Altec, just to spread good engineering knowledge and practices and SolidWorks stuff, we wouldn't even be here, right? That's first and foremost. Of course, SolidWorks User Group, without SolidWorks User Group, again, we wouldn't be here either because SolidWorks User Group is kind of one of the main reasons we're out here. As you guys know, we have 10 SolidWorks user groups within Altec. All right. I kind of manage those. I'll get to that here in a little bit. So without naming them, you can go to the SharePoint, our SWUG SharePoint, see all those different groups and who's leading which groups. This is one location that doesn't have one. That's why I was excited to come here, is hopefully pitch a SWUG group to you guys and hopefully see if there's somebody amongst your cohorts that might want to step up and take that SolidWorks user group leader role. It's not a huge role. It's just managing stuff like this, having people come give presentations.
And it doesn't have to be these big things. It could be
a
30-minute, 45-minute lunch.
Exactly. And SolidWorks is going to pay for food to come in and feed you guys and give you cool swag like we've got up here. And then you get the cool content. You get somebody like Daniel from SolidWorks Certifications, or you get Go Engineer, one of these guys back here to come in and give you a presentation, or me or Brad or whoever, right? There's a lot of people in the world that have great content about SolidWorks. And so if you decide that's something you want to do, please reach out to me. I'm going to help you get into that path. We'd love to see a SolidWorks user group form here at Indy. Along with that, we have ZHP. They've been a huge sponsor for us last year and this year, and going forward, they still want to help us out with that and keep us going. So they, as Brad said, donate these computers for us during the week and maybe getting us long-term loaners as well. So that we can show off these machines and how good they are to let people see, you know, what kind of content's out there, what kind of hardware is out there for people. 3D Connection, another great sponsor. each trip, and that's why I'm glad you guys are sticking around in this meeting, because each trip, 3D Connection has given us the opportunity to give you a Space Mouse Pro. Right? And so
You have to stay the entire.
you gotta stay the entire time. We'll do a drawing at the end for the Space Mouse Pro, and then of course tomorrow's meeting, if you're in person at tomorrow's meeting, there's an opportunity to get the Space Mouse Enterprise. Right? So it's really cool stuff that they're donating and helping out. Go Engineer, right? In the back of the room. GSC, Hawkridge, Converge, Swift, all those guys are resellers in the area. And they all do great. They've all donated either money to help out with the trip, or like Go Engineers got some gift cards up here we're going to raffle off here in a little bit, $25 Amazon gift cards. And so they're really helping and being here, just being here and being able to get the word out about what their mission is too is great. Ashley Furnitures is going to have us on the last final stop of the tour. And so we're going to actually be using their facilities and stuff up in Arcadia, Wisconsin. So that's going to be pretty neat too. So just a shout out to those sponsors for all that they do to make this IronSWUG trip happen. Okay, now to get started. Now I'll try and not be too long-winded. I've known to been long-winded before, but I am second, so I'm gonna try and keep it brief because I know we've already been in here for a little bit, and I want to keep you too much longer. But I do want to help you guys understand what design intent is, right? And design with intent, that is the master plan, right? This is almost a twofold presentation, as what I'm giving tomorrow is going to be design for manufacturing. I feel like almost these two presentations go hand in hand, right? I'm not going to try and dive too much into one or the other. I'm going to try and just stay focused with design intent for this. So just stick with me. Another cool thing about IronSWUG, I'll go ahead and throw this out there before I get started, is go to ironswug.com. If you want to see the next two presentations we have for the week, so for tomorrow and Friday, go to ironswug.com, go to watch online. Just give us your email. We're just going to send you an email, say, hey, we're getting ready to go live, so that you can join these guys on Zoom and watch those other presentations. Because everything we do, every year we do this, and every presentation we give is brand new. Nothing's recycled. We always give brand new presentations. So this is one that we come up with for this stop. So my name is Adam Ebernickel. I'm a project designer in the product engineering department of Altec Industries. For you guys, you probably know we do the bodies and stuff. For the guys out in the world, Altec does bucket trucks, digger derricks, tree care, dump bodies, a lot of different stuff. Anything utility uses, pretty much, you can think that that's probably coming from us. I also teach in the adjunct engineering department, applied engineering department at Mainland Community College. I do about 3 classes a semester there. I just really enjoy teaching and talking to people and giving back and helping people learn more about what I'm passionate about, right? I lead the Western North Carolina Asheville SWUG group. All this stuff I've kind of started doing when I came into Altec, so it all kind of just fell in place for me, I guess, and helped drive some of that passion and enthusiasm I have around the SolidWorks product and engineering in general. But I've been doing that for just as long. And through that, right before COVID started, I became the SolidWorks user group committee member for the whole Southeast. So that's basically Mississippi, Tennessee through the Caribbean, as well as all the Altec SWUGs fall kind of underneath my stewardship with the committee as well. SolidWorks champion. That's a lot of fun. We do have some champions around Altec in different locations. It's kind of like SWUG, but not. It's SWUG without the SWUG, maybe. It's a lot of people that just are passionate about software, passionate about giving back, doing projects and little things on the side, and working with SolidWorks to even prove out some of the software that they roll out, some of the new software and things that they're rolling out, being able to just play around with those and see how they work. If it's something you're interested in, there are prerequisites to becoming a SolidWorks champion, CSWP, and a lot of other things. Just go to Google, type in SolidWorks champion. There's an application in there. Usually try and look through that about once a year, and looking at actually having people be sponsored to become a champion too, just because we want to make sure that we're getting the right people as a SolidWorks champion. And I am certified SolidWorks expert, just like Brad. Went through that process many years ago, and I found a lot of useful tools out of the certification program. Not just, I felt like it was a great pat on the back that I knew what I knew and could prove what I knew, but I felt like more than anything, and one thing I hear from some people is, well, the certifications don't really touch on what I do, right? I'm doing sheet metal, I'm bottlenecked to sheet metal, so why should I do these certifications that are different? Well, my answer to that is it puts more arrows in your quiver. So when you come across a problem that you're stumped on, you have resources and ways of thinking about it differently. Use an example of where I was trying to flatten a piece of sheet metal and I couldn't get to flatten the way it was done. So I went and used surfacing to do it, right? And so I feel like that's what it does for you. It gives you those tools and resources and know how to do things different ways. All right, so I'm gonna give you some key takeaways here for design intent. And so it's gonna be basically what is design intent, how to use design intent, and who does design intent benefit? I had one picture on here, right? And when I had that picture on here and I was developing this presentation, the more I thought about it, the more I thought of this. I don't know if anybody in this room, well, there's a few people in this room probably old enough. So this is the older thing that people used to use to keep kids off drugs, back with the DARE program, DARE to something, kids off drugs, whatever, right? And so this was the big advertisement that went around America, said, this is your brain, that's the egg, and this is your brain on drugs or crack or whatever it was, right? And it's just scrambled in a pan. The reason that brought me to that is because I have this slide that says, this is design intent. This is your design without intent. Right? And that's what I guess kind of drew me to that. But basically, when you start a design and you don't have design intent, just think of it scribbling on paper. It's the unknown, right? It's behavior that's not really understood. But you can see if you don't have design intent, you're just all over the place. As you start to create the intent behind your design, you see things start to normalize. The informed user has intent to where it reaches a level where it's kind of stable, right? And then that design is rendered in intent or of intent, right? So we're looking at what is design intent. And so the first thing I wanted to look at, and I love the SOLIDWORKS resources, the help tools, you go up there and hit the little question in the top right-hand corner of your file manager bar. And it says, this is what SOLIDWORKS says, right, is that design intent is how your model behaves when dimensions are modified, right? I would go a little bit of a step further than that and say that design intent is the method used in computer-aided design that defines relationships between objects so that when you change one, it's going to automatically propagate another one, right? So that way they kind of go hand in hand and they work together. In SOLIDWORKS, we refer to design intent as the plan of how a model should behave if and when you change it, right? An example of this, I would think, is going to be, say, this image right here. Whether it's a extruded stud coming out of a plate or a hole in a plate, how do you design that hole? What do you expect that design to do when you change or modify the plate or the hole, right? What's going to happen there? So SOLIDWORKS captures the intent of the design and includes relationships, parameters, and how the models are going to behave for you, right? But in thinking of design intent, you also have to think, what is parametric modeling, right? Because that's almost what's kind of dictating and helping us out with our design intent, right? So what is parametric modeling? Well, everybody remembers the days of AutoCAD, right? The software that shall not be named that Go Engineer started, we found out today, right, is when you went and messed with AutoCAD or one of those type of softwares that didn't have some parametric understanding to it, you would draw it, and if something changed, what'd you have to do? Yeah, basically delete, redraw it for the most part, right? Especially if it really changed. And so the key advantages of parametric modeling is when you set up a geometric model, right? The shape of the model can be changed as soon as those parameters are changed, right? As soon as you go in and you change a dimension, it's going to change, whether that be, those dimensions or the curvature are modified, and keeps you from having to redraw those features or that model. Now, one of the challenges within parametric modeling is finding that right balance of over constraining and under constraining, right? Anybody see ketchup and mustard in your models? Yeah, that's that over constraining and non-resolved type stuff, right? Or under constraining, the blue sketches. Do we need to play Toby Snars's the fully defined every time? We've already talked about that, right? And so no, so really in order to avoid that over constraining and under constraining, you have to find the right balance and minimum number of types, constraints, and relationships necessary to fulfill that design intent. All right. And so let's look real quick. Kind of got ahead of myself and didn't skip through this. Let's go ahead and show the slide. So yeah, finding the minimum number of constraints to make this work. Let's jump over to the CAD mobile, right? Let's look at this plate, for example, and how these holes are dimensioned. What happens when I change the overall measurement of this plate? Just based off what you've seen here and how I have those holes constrained, when I change this and I change maybe this dimension to a 30, what do you expect those holes to do? Yeah, go out with it. Go out with each end, right? They're tied to the ends. So maybe my design intent is that I always want holes to be 4 inches from the edge, right? Maybe I need that as a parameter. Why not design it that way? Because if I go in and design it maybe a different way, say something like this, what's going to happen there? Yeah, I mean, they're going to stay in the middle. Maybe I always need those holes to be 4 inches from each center, from the midpoint, 8-inch overall, centered about the mid, right? Maybe that's where the mounting is. And so if I know a mounting is always going to be there and I just need the plate to get longer, maybe it's a spacer and I'm just trying to mount it to the same holes. There's my design intent for that. My hole spacing is always going to match and the spacer is just going to get bigger as I need it, right? And so when we think about that and kind of going back to that one slide, there's a lot of different other things we can think about too. Okay, so we're going to talk about design intent with parts a little bit more, just basic parts. We're going to talk about a simple cylinder. How many different ways do you think you could probably draw this cylinder? Well, let's look at it and let's kind of think about it. And there may even be more than what I have on here, right? But let's look at it. All right, so the first one we'll say we can extrude it, right? And this may be the best option for controlling the overall depth of it, right? Maybe the depth is what we're after. Maybe the height of it or the length of it. Maybe that's the ultimate goal. And so we're going to go extrude. My opinion is I always like to extrude about mid-plane, right? So everything's balanced with the planes. It also helps with mating stuff, especially when you're trying to think that planes are your ultimate guide because anything and everything else can change but the planes. Right? So that's always a good key. Well, maybe we need to revolve it. We can create it as a revolve, right? Well, a revolve is going to do what for us? It's going to help us with the revolution. Maybe we don't always need it to be 360 degrees. Maybe we only need it to be 180 degrees. Maybe we only need half a pin, right? What if we swept it, right? Now, when I do for rods and pipes and stuff like that, I tend to like to use sheet metal. Right? I tend to like to use sheet metal because I can utilize those features in sheet metal, go in and put radiuses on the outside or even sweep it after I create the sheet metal, because then within the sheet metal, I can use my bend table, right, to know how to flatten it and know what my flat stock is going to be before I bend it. Now, the caveat with that is it has to all kind of be along one plane. When you start going into another axis, right, then it doesn't work so well. And maybe that's where you need the sweep, right? Maybe the path of the direction is more important than maybe the sheet metal feature is. And so I always tell people, especially in some of the other presentations I've gave, Basics 101 and how to maybe define things, and my sheet metal advanced presentation, I always caveat things. These are things I say you probably should do, but design intent is the master. Where you plan on going and perceive that model to be, how it to be utilized and grow in its life cycle is going to be the ultimate thing that trumps all. Okay. But each way, and I tell this to my kids, and I'm gonna preach it here too, because I tell my kids, life has consequences, right? Whether good or bad. You can make a good choice, you can make a bad choice, you're gonna have a consequence either way. Modeling's the same way. I don't know about you guys, but have you ever modeled something 5 years later, go back and look at it and say, what the heck was I thinking? Right? And so we learn from those consequences. And I'm hoping this presentation helps That's okay.
Who was dumb that made that and look?
And, oh, it's me. Yeah. Okay, so to save time, I'm not gonna jump into CAD and show you how to model a rod based off of those. I'm gonna save you that trouble there. And we're gonna kind of skip through just to help out speed this up a little bit. Equations and dimensions. This is big. Not only in just your normal day-to-day design intent, but when you look into getting to automation, DriveWorks, KB Max, that kind of stuff, and even more so with certification, right? Because another way to ensure design intent and flexibility within your parametric modeling is to utilize equations and expressions, basically taking what you're trying to input into your design and making it a mathematical property that can actually be flexible and link those parameters and constraints to other things, right? And I mentioned this, I think, day one in Nashville. I did a tips and tricks let's play as a little game we did. And one of the things in the game is, can SolidWorks compute pretty much anything you put in? If you put 1 + 1, is it going to tell you 2? Yeah, it is. But one thing you have to keep in mind is, although it will do that, if you want it to constantly compute, you have to put an equal sign in front of it, right? Once you put the equal sign in front of it, you'll notice it'll give you the Greek E, the summation sign. It'll actually add it to the dimension itself, so you'll know the difference. If it doesn't have that and you intended for it to always calculate the equation, then know that it needs to be there. If it's not going to always calculate that equation or compute that equation. It's just going to do it once for you and be done. And create those to where they're dynamic and adaptive, so that you'll know what it's going to do when it changes. I also suggest to give some of them some types of names and stuff. So like I'll use this one for an example. You can see in the image, it says equals D3 at sketch divided by 2. Well, what the heck is D3 at sketch 2? Where is that? And I'll talk about it a little bit later. You can go in and name and put stuff in folders, but you can also do that on the sketch level and name your sketches. You can now. There's a little bit of diminishing return there, right? But name some sketches. If you think it's something you're going to use, name the sketch. And then when you go to type an equation, you know what the name of it is. And you don't have to say D3 at sketch 2, right? So keep that in mind.
David said, especially critical sketches.
Especially critical sketches. Especially if you know that you're going to go into automating, right? If you're using KB Max or DriveWorks and you know you're going to do something with that, or maybe we don't use them as much in Altec anymore, but maybe you're using design tables and doing configurations and stuff. Dude, that's so important, because when you get into that table and you're looking at D3 at sketch 2, you don't know what dimension that is. That should probably be the length of your rod if we're talking about rod, right? Rod length or whatever. But yeah, create those sketches dynamic and adaptive so that you can adjust them for different scenarios, conditions, and for different requirements. Use global variable equations, right? This is not only big, like I said, and this I'm preference this one back to certifications, right? If you want to win at certifications, CSWA is probably not super important, but by the time you get to CSWP and you're moving forward in your certification, you better be using global variables. They're going to tell you at the beginning of the equation, at the beginning of the question, that A equals B equals C equals. Set those up. Get it out of the way. Because then when you go to problem 2, 3, and 4 that match problem 1 and all they're doing is changing global variables, you're already set up for success. Right? It builds an intelligence that you don't have to worry about. It helps your model grow and relate to those equations to where it's almost intuitive, right? Who loves their cell phone when they can go to an app and it automatically kind of knows what you're thinking and what you're doing? Not so much that it's, of course, listening to you in the background, but, but that it kind of has an idea of you being a user. I'll give you an example. We jump on the motorcycles. We're heading to Milwaukee next. You think my GPS has kind of got an idea I'm going to Milwaukee next, and when I go jump on the bike and I hit GPS, it's going to be right there for me? That's awesome. That's what this does. It does it for you, and we'll talk about you and the other people later, but that's one great thing. And again, I already talked about this, touch this one. Know the difference between the equals, with and without the equals. You'll see the summation sign if you set it up right. You'll also, if you're using global variables, you'll also see the little world off to the side. That'll let you know you're using that as well. All right, so let's jump over here. I want to just illustrate a couple of things. Anybody recognize this? Anybody in Zoom, you guys recognize this model? Yeah, few people nodding their head. Yeah, it's one of those practice ones for the CSWA, right? And if you come over here, you notice these equations are set up and such. I can go in and manage them, and if I want to change these, everything's just going to proportionally grow to the way I need it to be based off those values that's given in that. There's a couple of ways to set this up. Right. And I like to just show this real quick because a lot of people think you have to do it one way or the other. And in case you're doing it one way and want to know the other, we're going to look at that real quick. I'm going to open up just a quick part. Let's go in. Oh, yeah, let's go in and just draw a sketch here. Grab it on the front plane. Go here. Here. Actually, no. I'm doing sheet metal. Let's do just an extruded boss. Now, one good thing I like to show a tip and trick is, yes, I have automatic on-screen numeric input turned on in my system options for Altec guys. It's already set up for you. That way, don't worry about it. But this is great because I can automatically go in here and give a dimension. It'll grow the line to that dimension. And then I also have the second feature part of that where it creates the dimension after I do that, right? That's a great opportunity to be able to take advantage of. So if I want to come in here, I can actually say this equals A. I didn't hit equals. I had the shift down. Try that one more time. And it's going to give me that little global variable. So I don't notice in the feature tree, there's no equations built yet. I don't even have an equation folder there, right? And I can say, yeah, let's do that. And I want to create a new global variable. And I want that global variable to equal 2, right? And I'll say, okay. Now it gave me the summation and it equaled it out. See that? Now I have an equation table. I can come in here to the equation table. I can manage those equations. I already automatically have that on the fly. Global variables made easy, right? If I don't have global variables set up or anything like that, say I come to this guy, there's no equation set up. Just know all I have to do to set them up is come in here and right click on the top level name of my feature tree, go to hide tree components and come down to equations. And then I can tell it to manage equations or show the file properties and it'll automatically turn that on and off in my file properties. So one of two ways that I like to use it. My opinion is if I know those equations are there, I'm probably just going to go in and do the latter one, right? I'm probably just going to go add the file to my feature tree and just list them all out. If I'm kind of thinking about this on the fly, then I'm just going to do it on the fly, right? And just make it quicker and easier on myself. Yeah, okay, one more thing. Go back to this. And so that difference being, when we look at this, and you know this is set up right, let me, I'm just going to delete that dimension real quick. Click. And so here's this difference that when I now have this regular dimension, if I say 1 plus 1, it solves it for 2, and you don't see any summation sign. And then if I go in and I hit equals 1 plus 1, I actually have to tie it to something. So let's tie it to the global variable. And the same thing holds true. If I didn't do this, I could say the same thing, equals global variable A, enter. Now look, I have a little world that shows up and I can toggle that. Well, typically there it goes. So toggle it to show the value or the letter, either one. Ah, sorry, I escaped out of it. One more time for the. There we go. Now notice it gives a summation sign. It tells us, hey, this is an equation. So that's how we know the difference of constant compute and not constant compute, right? And if we tied it to a sketch, you wouldn't see the global variable sign in there. You just see the summation sign. Okay. Naming and folder grouping. This goes along with the name in the sketches and stuff. I feel like this is probably more pertinent than the naming sketches, because it's the sketch naming and stuff. I feel is a little bit more far and fewer between than this is. And again, I caveat this with what I was saying a minute ago. There is diminishing return, right? If it's something you know you're going to touch all the time, I use this image for example, marker light hole. Does that sound like something you could probably change, move? Sizes are changing, different marker lights are being brought in. Maybe the location's in a different spot so it doesn't blind somebody or whatever the case may be. I think that's a good idea that you go ahead and you name that, because you want to know, hey, where in the feature tree is it, versus hunting and pecking. Which one was that I need to change, right? But then again, I don't know that maybe the edge flanges need to be named. I don't know that if I have some notches that they need to be changed or different things like that. This also indicates the different sketches. Go ahead and get this stuff out here and then we'll talk about it. Okay. It also names some of the sketches. So when you go in and you say, hey, this is going to indicate how high something is. For example, here's a compartment height or how deep the compartment is. If you went and looked at this, maybe this front flange here, it would tell you, hey, this is how high your door is going to be, your door opening needs to be. And maybe the values are already in there with construction geometry showing the gap you need for tolerancing or whatever, right? And so that's already included on each end, and you just have to change one dimension, but you have it labeled so you can be able to see that. So as your parametric model grows more complex, you need to use this smart naming to group and organize different things. And that's also grouping and organizing your folders all the way down to your mates, right? Let's think about your assembly. Anybody have mates that are mating maybe your body to your chassis? Anybody think that blows up when the body model designer decides, or, oh, let me rephrase this. I'm gonna put this back on FA. So when FA decides that the chassis, that the body floor needs to change for some odd reason, and when they change that floor, they come back and the body modelers change something, and now the floor doesn't sit on the chassis right and it's blown up. Well, what if you group those mates? Oh, sorry. We'll go to the chassis group, change the chassis. There we go. Somebody's got it, right? And so you group those mates where the body model mates to it or whatever, outriggers mate to the chassis, whatever that is, right? And so when something happens to a specific item, you can go and look at those mates just for that, right? Think how quick that can maybe help you in troubleshooting stuff.
Yeah, it says in multi-body modeling where you have hundreds of features, grouping and naming is no longer a choice, but a necessity.
Yeah, right. And again, there's diminishing return. And not every little bracket you make needs to have everything named in it, right? I mean, that just kind of takes time, and it's like, duh, it's a freaking angle bracket that I'm using to hold something up, or a spacer, right? I mean, you don't have to name everything. If it's a HDP spacer with 2 holes to bolt it, I mean, it's pretty self-explanatory, right? So diminishing return, choose your battles when it comes to this, and just be wise about it. Design intent, right? Naming and grouping can help you edit and identify your parameters, constraints, features, sketches, and components so that you can avoid confusion later on. For example, prefixes and suffixes or even abbreviations can help you out when looking at that stuff and coming back to it. And so when you can be a little more descriptive than certain things with other things and given that those, I would say, more consistent descriptive and nomenclatures, be consistent with those. So let's say, if it is a spacer, maybe we name all spacers spacer, right? Yeah, of course you need different ones, but when you know you're looking for a spacer, right? Or for example, when you know you're looking for a marker light hole, let's not just name it hole cut out for light. Let's kind of get a little consistent with it. Say it's marker light hole, right? And just be consistent with that so you know when you're looking for something, you're going to find it within that. Again, additionally, you can use folders for sub-assemblies, layers to group your design elements by category, hierarchy, and visibility. You'll notice that. He's talking about, you know, how you guys are trying to use some envelopes within your sales models like we do in body, and how we do some of that. And categorizing that with, let's say, completions and installed and weld on, that kind of stuff, that helps. And that also helps when you send it to the floor, right? Or when you're trying to do bill of materials and stuff. Okay. And again, here's an image for overall folder structure. Just kind of grouping things together so you know when something modifies or needs editing, you know where to go to do it. And so then there's some design intent with assemblies as well. Anybody do top-down modeling or even bottom-up design? I do a little bit of both, right? Bottom-up meaning you're building the parts and pieces and then putting them in your top level. Level down means top level down would be you're working in your top level and you're building or adding new parts or cutouts and convert entities and stuff from your top level and driving the information back down. So I do both.
In fact, there's even a mix of both at the same time.
Even a mix of both. So at the assembly level, the most effective method could be of building design intent through top-down design. All right, critical parameters and dimensions can be managed through external references, tab and slots, pattern-driven component pattern, and sketch-driven component pattern. Right? And so with that, you can later implement radical design changes, and rather than modifying a dozen things, you go to the source of truth and you modify it then and let that drive from top down. Right? And so let's talk about each one of these images and these different bullet points here. Not everybody uses in-context modeling, or at least retains external references. In-context modeling can help. You don't have to keep the external references all the time. As you can see in some of this nomenclature, you see at the top right hand of your screen with that ripped out page. And what do these mean? So anytime, I'll go ahead and start out with, if you're looking at this, you see a little dash with an arrow, right? It kind of looks like an arrow. That just means it's got some context to it. It's referencing something somewhere, right? And the first one has a little question mark next to it. Well, what does a question mark mean? Well, it means it's out of context. It's lost its line of thinking with whatever that context is coming from, right? Of course, without the question mark, with just the arrow, what I just mentioned, that's your in context symbol. The next one with the X is your broken reference. So this is one that if, let's say, you did create in context modeling and you were using an external reference, you could go in and break that external reference. And once you did, it would give you the X to let you know that it is no longer referenced outside of that model, right? I did a lot of research, and I've done it before this, but when the slot and tab thing came out, or tab and slot thing came out for SolidWorks back, I think 2020 or something like that, it only works off of external references right now. You have to either do it in A assembly or B in a multi-body design. And either way, it does great. It gives you slot and tabs, but it creates those references. And a lot of places can't use those references. I'm hoping that SolidWorks is working on that. I've been preaching to them every time I go to their R&D sessions and I go up to Waltham to their headquarters and do testing. And I think they're starting to bite into it and thinking they're going to try and push for that some way. I've gave them ideas on how to maybe manage it and make it work. But right now, for example, with that, if you go and create it, you have to go in. It creates everything smart and it's great. And then you go break the reference and get rid of the external references. Then you get the little X, but then it's really dumb and you have to go back and redimension everything. So it's not smart anymore and it's almost a waste of time. You might as well just draw them yourself. Tab and slots, since I just mentioned that, I won't go too much more over that because I kind of related it into that. I did miss locked references, so you can actually lock the references if you create them to where they don't change if something changes. So it's almost like breaking them in a way. It just doesn't change them. I guess you can unlock it and rebuild or import that data. But yeah, you can lock it, and that gives you that little asterisk symbol. But with tab and slots, I wanted to bring it up not just because SolidWorks isn't doing it without external references right now, but you can do slot and tabs without the slot and tab feature or tab and slot feature. And it is going to help. Said I wasn't going to cross bleed, but for design for manufacturing guys, it's going to help. It's not going to help them put your stuff together right, but it's going to relieve the headaches from you when somebody comes to you and says, "Why is this off?" and you find out they put it in the wrong place because we didn't, poke-yoke it. Yeah. I'm not a fan. Do what?
He said it could be a double-edged sword. Managing the external references can
Yes.
create challenges without best practices.
Exactly. And context is a double-edged sword, and that's probably the biggest reason we don't use it, aside from PLM, is just having to manage that, right? So yeah, and next to that, and I'm not a big poke-yoke fan, but it helps, right? Pattern-driven component patterns and sketch-driven component patterns will help drive information to where you don't have to remember to do certain things. It will also speed up your models and create these large models that Brad spoke about earlier, more efficient, right? Because it's not having to count each instance. For example, this plate, and I'll go ahead and show you just a couple of things real quick. But this plate here, if you had to go in and mate every one of those weld nuts, right? That'd be a lot of fun, wouldn't it? And then what happens when the design changes or somebody says, "Oh, the manufacturer decided to update his mounting pattern." Then you got to go fix it and change it. That's a lot of fun, right? But then SolidWorks is also calculating that data for every time that you've had to mate that, right? Because it's having to go through and solve those mates for how many different ones you have, or pattern's going to be a lot quicker. And there's some, I'm not going to get too in the weeds with this, but even within patterning, there's options for geometry pattern and stuff like that that even makes things faster in that aspect. But let's go ahead. I didn't know he was going to put this in his, but I put it in mine a different way. So that was a surprise when I seen it in his. Like, I scrolled through my thing. I'm like, I got to, but wait, there's more. But wait, there's more. So this isn't all the end all be all, right? What I just said is just the tip of the iceberg. It's just to get you started understanding and getting your gears turning about design intent, and then seeing where it grows and goes from there, right? Well, that's the great thing about engineering is there's always good things, good practices to learn, to develop. It's not stagnant. The moment engineering becomes stagnant is the moment that the world ceases to exist, I feel like. So, I mean, we're the ones that are challenged to create new and innovative things. So know that that's there. Now let's jump in. Or I'm sorry, let's go to the CAD mobile. And we'll jump over to this model. And so I've got this set up for both ways just to illustrate two different things of the way you can do these component-driven patterns and sketch-driven patterns. Right now it is set up, I believe, for a component-driven pattern. And so if I come over to this block and I change any of these components, maybe the linear pattern, and I edit that, and maybe all of a sudden they decided they didn't need it to go 7, they only needed to go 5, right? And I change that. And then I come back, it automatically updates. That was so easy. A lot easier than finding out which ones got screwed and deleting them and then trying to fix the other ones or restore mates or whatever I'm doing, right? That's with just the component-driven pattern. So all that is me creating holes, what I needed, right? And creating that design intent and then creating a pattern developed off of it. In this pattern, you can also see that I understood that maybe the manufacturer didn't need all those holes. So I was able to go in and turn some of those off and select different ones to skip instances. There's so much in the patterning thing that if you just get in there, I mean, Brad does a great job showing varying pattern, where you can actually draw a sketch and have the pattern follow a sketch in the background. So that's pretty cool, for cutouts and stuff. So even that's there, and there's just so much in here. We have presentations just on patterning, right? So I'm not gonna get too much in the weeds with that, but so create your pattern how you need to here. And then when you come in and you need that hardware or whatever it is, you only have to do one and then tell it it's a derived pattern, and the rest of them are just linked in. Right? As long as you don't get rid of the seed one, everything else is going to follow right. Okay. So I'm going to actually suppress this one here and this one. And I'll come back to this model. And I'm going to suppress this pattern and cut out. And instead, unsuppress just a sketch, just a simple sketch that I have set in here. So it's kind of the same thing, just a bunch of points, sketch points. And then when I come back on this one, if it loves me, it'll work, right? It's just located by sketches. So maybe you didn't need the holes, you just needed weld nuts, so you could maybe put a jig together and have some kind of locating for some bolt for them to line stuff up with. I don't know. All right, and so you can use sketches to do the same thing. So that's just one instance in where you can look at that stuff and see how patterns can work with you and for you, all the way from the part level to the assembly level. And also create those files and make them a lot more efficient within SolidWorks and the calculations it's doing, but also for yourself when you come back and you're trying to fix something or change something. Who benefits? You, the designer. You benefit. Because when you do go back and look at that model 10 years later, and you don't want to say, who did this? You say, that was pretty smart. I know exactly where that marker light hole is. Right? So, I mean, it gives you a leg up when you're coming back to stuff. So you benefit because you have the resources and tools to help you succeed down the road. Your checker benefits. When you hand this off to a checker and he's going to look for certain things and make sure they're up to standard or whatever the case may be, he doesn't have to spend an extra 30 minutes checking your work because he's having to hunt down certain things or maybe certain cutouts that need to be a certain size or whatever those standards may be. He can go right to him and look at that stuff and see, hey, this guy's got it together. I can trust his design probably a little bit better than I can the guy that didn't. Right?
You can trust my design.
Yeah. Your successor, or maybe the person that takes on the job or the responsibility after you, when you set up a part for success or an assembly for success with good design intent, the next person, even though, yes, they're going to need training and they need to be brought up to speed, but think how much easier their job's going to be when stuff has been labeled, when sketches have been worked on, when patterns work the way they should, that they're not having to try and figure it out and possibly even mess something up and cause havoc for the shop or even the customer because they're trying to figure things out on the road of hard knocks. All right. Your customer succeeds, right? They benefit for that same reason because they're seeing consistency, efficiency, poke-yoke, right? I mean, they're seeing keep it simple, right? All those things help the customer receive a better product and a product they know they can depend on and rely on because people are trying to give it the best that they have, right? They're giving 150%. And then your company. Because when you succeed, when the checker succeeds, when the successor, the customer, and everybody else succeeds, the customer is inevitably going to succeed and benefit. So I would say everyone involved will benefit from designing with intent. I always like to wrap my presentations up with if I was you or me kind of thing. If I was sitting there taking notes, maybe what I would have said, what I would have wrote down. I would say that models react to intent, right? So it was the old saying that you only get out what you put in, right? So whatever you give it, it's gonna do what you tell it to do. I know when I first was going through school, I remember my professor, I was having a problem with the program and I was getting aggravated with it. And I was blaming it on the computer, right, on the program. And my professor said, dude, the problem lies between the keyboard and the chair. Right. So, and he had a good point, right? And then of course he said, if you can't fix it that way, a sledgehammer will. But yeah, so yeah, you get out what you put in. So it's only going to react to what you give the intent to be. There are many ways to do the same thing. There's not one way that's completely right, and I'd say there's many ways that could be completely wrong, but not one thing is completely right. You can skin a cat several ways in SolidWorks, but as long as you do it with intent, you are going to succeed. Use global variables and equations. They're super easy to use. And if you know it's going to, and I had one, and I probably should have pulled it up and gave a little more time to it, but in one of those plates, and it was one that I did pull up and showed you, it showed those holes being kind of centered, right? 8 inches about the center, 4 inches each side. Well, I had 8 inches there, and then I said 4 inches, but I actually had that equation. I had it as an equation tied to the 8 inches and said that dimension divided by 2, because no matter how long that got, I always wanted it to be centered. That's the super easiest equation you could probably use, and works every time, and it's just super efficient. Yeah. So use global variables on equations. Use feature patterns and assembly tools. There's lots of stuff in there that can help set your models up for success and your designs up for success. And know that when you put in the effort to have good design intent, everybody's going to benefit. So calling to action here. So another thing I like to do with my presentations is just to say, create better designs, right? Give a sincere effort. Have passion and enthusiasm about what you do. I guarantee if you have passion and enthusiasm about what you do, you're going to love your job. And just design with intent. Bottom line, design with intent. And Richie Norton said, intentional living is the art of making your own choices before others' choices make us. Now that's kind of a life tip, but I would say in relating it to SolidWorks and design, make those choices before your models and designs make the choices for you, right? And then Aristotle, I love using some of his quotes and phrases. He's a great philosopher. He said, excellence is never an accident. It is always the result of high intention, sincere effort, and intelligent execution. It represents the wise choice of many alternatives. Choose not chance that determines your destiny. And I'll open it up for questions. Anything in the chat? Okay. Sounds good. I'm going to put this, yep.
Survey